All right, good afternoon, everybody. Good to have you here. We're going to let everybody join in for the first couple minutes here. I'll give it just a minute or two, and then we'll start with just some introductory time. But good to meet you or see you. I'm Alex. I'm from SimSystem Americas. I'm the marketing director for us here. Help on marketing, sales, a little tiny bit of technical. But I'll be your host for today. And you can see Greg Everett. I'll introduce him more formally in a second. But Greg's going to be our panelist of the day and the topic of the conversation. So we'll just hang tight for another minute here. And I'm going to actually activate a poll for you. So if you're here, we just got some demographic information on the poll. You'll see that come up. And yeah, go ahead and just tell us a little bit about your role, who's here, what solutions you currently use in your lab, if you're in a lab, for your CAD and your CAM, how long you've been doing it, just so we get a good understanding of what we might expect on some of the questions and things like that. And then tell us about your current milling outcomes. Yeah, we want to know kind of what's going on in the room. You guys coming in hot and you got problems, or is this more of a, hey, we kind of like what we've got going on, but we know there's more to learn. Help us understand kind of who's here. So go ahead and fill out that poll. I'll go ahead and just start the main screen share, and I can tell you a little bit about us and SimSystem while we're waiting to get into the main topic. So let me go ahead and I will share my screen. I think it should be coming up. I just need to get one more thing.
I see it.
Good, yeah. Awesome, great. Welcome. Like I said, I'm Alex from SimSystem Americas. And SimSystem, Greg and I were just discussing before the call. It's funny, not everybody even knows SimSystem. I hope that logo isn't too unfamiliar for you, but maybe the next one will look more familiar. SimSystem is the developer of many software solutions, one of which is Millbox, which there you go, Millbox. And today's conversation is going to be about CAM or the machine. CAM and the machine, not CAM versus the machine, certainly, but just a conversation where we can talk about diagnosing and improving your milling outcomes. Greg's talked about this before, but we want to get more information out because what's acceptable in the common lab can be surprising in terms of milling quality outcomes. And not everybody gets what they're expecting off of the mill. But the hard part is knowing, what am I looking at? And what might be the problem? And truly, it's CAM or the machine, CAM and the machine. It could be a combination. There's not really necessarily one to blame. It's kind of a strange juxtaposition there to say up front, because realistically, it's more about, do I know what the problem is? Can I translate what I'm seeing on this physical part into possible outcomes, and then can I go through a checklist to kind of eliminate some of those possible problems? And then if I can identify one, what do I need to do inside the CAM or inside the machine to fix that problem? And it could be one, it could be both. Not to place any blame in a negative way, but more to say, oh, well, what's the problem? How do I fix it? And so I love the conversation. I've liked what I've heard from Greg in the past, and I'm excited to bring it here. So Greg's with us. A little bit more about SimSystem before I give it over to Greg and together. SimSystem, we're a CAD CAM software developing for industrial and dental manufacturing company. So we're based out of Milan, Italy, and have several global locations. But we're based out of Milan, Italy. That's where our development team is. About us, though, we're an in-house software developer, which is unique in the CAM space, because we'll do our own in-house software changes. And so if you're wanting to make a change or implement some kind of feature request or something, SimSystem is very efficient and versatile in our staff, where we'll be able to implement those changes directly, which is why our pace of updates can be really fast paced, and people can use even beta versions in some cases. So we have our own in-house team, and really the name of the game for our softwares is about putting the automation first, making the UI as clean and intuitive, and not giving a lot of options in what you're looking at, so that anyone, it's very easy to pick up. But for those of you that are more familiar with a software that has a lot more to look at, even like some 3D, our original software. All those manual designations and deep intricate details are available, but sometimes you don't have the knowledge, and Greg will show some of those places actually today in our time for strategy stuff. So that's us. We're, like I said, in Milan, Italy, and I'm sitting in Indiana, USA. That's our US office handling this hemisphere. Great team in all the entire hemisphere from Canada to US to South America, Brazil, Latin America. And then we've got several offices. Great thing is that you can get support in your country. So no issue with strange timings for your calls for support. And just some base facts for us that you can see just when doing it a long time. We actually have 15 software products that are out there, not just Millbox or Make and Mill, which you might be familiar with. But great, strong company sim system. Millbox is kind of the CAM piece we'll be looking at today, probably a version, an edition, but the version isn't the primary concern. The interface can look slightly different. The actual icons and features is all going to be the same, more or less. There might be some very, very small differences where maybe the part type might say something slightly different, I know, in some division. But moving on, Millbox is a great dental cam solution. And like I said, you can see the UI. It's very intuitive, easy to use, simple icons, ready for any lab to use, but has so much behind those icons deep into the bones of the software that you can go make your changes. And so it's a great, accessible, versatile, and strong CAM software for the market. And of course, a good thing is that Millbox can be used with any open mill. And so when we talk about the machine, we're not talking about a particular machine. We're talking about a milling machine. Like, does it have how many axes? Does it have a spindle? Those kind of just, what are the outcomes possible there? But Millbox can unite all of your machines because it's an open CAM software. So that's just a great thing to know. You can have one CAM to power whatever is going on in your configuration with open machines. So that's a little bit about SimSystem. And again, I'm Alex, Director of Marketing for SimSystem Americas, and it's great to have you here. I'll introduce Greg, and we'll more or less get into our topic. I'll check back on the poll here in just a second. But today with me, I've got the illustrious Greg Everett. And Greg, it's fun. Back when I started contractor for SimSystem, you were helping us out at one point, and Greg was one of the first people that I got to meet. We had a mutual project, early on, Greg was there. I could see his knowledge for the industry was really strong, and we had a short time together. And really happy about. It's cool. He started a company. Greg, tell us about what you're doing now. I can see machines in the background. Tell us a little more.
Oh yeah. Hey, well, thanks for the intro. It's weird. I'm sitting here reading this thing that I wrote like 3 years ago. I'm like, oh man, I need to rewrite that.
Yeah.
So my deal is I worked in a lab 10 years, did milling center production. I learned how to break things and fix things, and I over time I got pretty frustrated with like just the state of technology and the way that it's presented, sold, and supported generally, in this industry.
Sure.
And I've always been ambitious to start my own company. And so in 21, I had some opportunity and some things lined up, and started Dention. We're here to help labs make sense of digital and get good outcomes. And to help spread the word that, the machine outcome, the printing outcome should be good. You shouldn't be messing with it. And if it's not, we got to look at it. And so that's kind of what the subject matter on this webinar, podcast, whatever you want to call it, is going to be. So Alex, when he hit me up, I'm like, absolutely, man. Anytime that we can, spread the word, or, at least plant some seeds in people, as far as their mentality about these processes, always fun to jump on and do stuff like that.
Absolutely. And it's rare knowledge. It's not covered, often in a lot of places. And so it's gonna be great to dive in. Let's look at the poll here quick. Looks like we just got a broad range, and a lot of Millbox users mixed on the experience, but everybody's fairly happy with their milling outcomes. So this will be fun to see what comes up as we get in. I mean, lowest score is a 3, and most are in the 8s to the 10s. So Thanks guys for the poll. I got a question. We'll just start off with right away, and then I want to see some pictures of what you're seeing out in the industry. But
Sure.
maybe we'll start with maybe can you still see my screen, or am I not sharing? Well, I'll ask you anyways. What's the
You're.
Go ahead.
Oh, I was gonna say I'm looking at your desktop with your Slack channel open.
Oh
I
no,
think
let
everybody.
me.
I think everybody is.
Yeah,
I
there
don't
we
think it's a
go.
big deal. A temp
Yeah.
code, guys. If you don't know what temp codes are, you now it's
I
an
needed
important
one.
part.
Yeah,
Yeah.
yeah, absolutely. Great. So we talked about this. Really, if we're going to start out talking about cam and the machine, well, what's the relationship between the cam and the milling machine in general? So I remember we were saying, really the machine is just told what to do. The machine is the equipment, and the cam is the brains in it, and it assumes an optimal environment. It assumes the machine is in a perfect condition. The cam does. What else would you say about what's going on between the cam and the machine, how they relate with one another?
Well, it's pretty common. Like when we're in a like a sales process to sell a machine, people are surprised that they need software to run it,
Mm,
and so it's not really like that relationship between the smarts and the kind of dumb implement, which is the tool, the machine. It's not really that. There's not a lot of attention given to that relationship, and it's extremely important, right? So, the machine is and I'm probably going to irritate machine manufacturers by saying this, but it's literally the dumb end of the stick. Like it's just going to carry out the command. It's reading code and it's doing its best to try to go through and do what that code is.
yeah.
And so where does the code come from? The code comes from the CAM software.
Mm,
And computer aided manufacturing. We're using the computer to turn our STL mesh into lines that the tool can follow and
mm,
create the unit, or
hmm.
the partial or the whatever kind of part you're making. Um, and so the machine's trying its best. The CAM software is doing its best to drive the machine. But sometimes, if that relationship breaks down,
Mm,
that's where we can create defects.
yeah.
And maybe the machine doesn't carry out the command right, or maybe there's a setting in the CAM software that's telling the machine to do something it can't do.
Right.
And there's all kinds of scenarios that come up. And once you put yourself in that frame of mind where we got the brains in one hand and the kind of dumb end of the stick in the other hand.
Mm,
It kind of helps from a troubleshooting standpoint. Because like Alex, I'm sure you see this, but if you jump into like the groups or the forums, and somebody posts, "Hey, I've got this problem with this machine," and blah blah blah, and then you immediately have people going, "Oh, it's this, it's that, it's
right.
this or that,"
Yeah.
or they blame. It's just it turns into a blame game.
Yeah,
Um,
absolutely.
and almost zero of those conversations go to, "Hey, what are the facts and what is the root cause? Let's
Yeah.
figure out the root cause so that we can kill it, right, and solve it so it doesn't happen again."
Right.
Um, and everybody's always blame game, and it even happens. It even happens in the back, like the back end sort of conversations, like the it's either the tool or the machine or the cam or the
Right.
customer. Like everyone's like, "Ah, it's your fault. You need to call this
Right.
guy," and it's like, no, just freaking collect facts, look at it scientifically, don't change more than one thing at a time, and figure out the root cause.
Yeah.
And Alex, it's really funny because uh, I I feel like Dention is a bit unique in taking that approach.
Sure.
And but it's why we grow the way we have, and by word of mouth, and we're solving problems for people.
Mm.
And the same thing goes for Millbox. I mean, your guys' team is awesome. Anytime I need something, it's always there, like immediately.
Mm.
So I'll stop that rant. And Alex, you know how I
Yeah.
am. I will
Yeah.
absolutely take tangents, so you gotta reel me in.
Yeah, no, and let me
uh,
say here now too, like we have it'll be an open Q&A at the end,
mm,
certainly. But all throughout, if you guys have questions, I'll monitor our chat. And if we have any kind of question that comes up just throughout our conversation, I'll try to, feed questions in. But yeah, feel free to ask your questions. And right away, I think we're thinking, what can those possible breakdowns be between establishing that the cam is the brains, and it's assuming that all is operating perfectly, the machine is perfect in the condition, everything's how it should be. Yeah, what are some of the outcomes you're seeing? And then let's talk about some of the breakdowns that are possible there that are common. So yeah, Greg, I think we discussed our first one, roughing lines
Yeah.
through the finish. So but what are you seeing out there right now? You have anything
Well,
for us?
yeah. Well, we get like our primary business is repair, and so I we do see a lot of most of the people that we interface with are having problems just because of the nature of what we're doing. They're reaching out because their mill's not doing what they want it to do. And so we did put together kind of like a quickie list of the common defects that come across. And it's by no means complete. There are definitely others. But yeah, and they're also not in any particular order. So I think it might be like good to perhaps talk about what does a good result look like uh, quickly, um, because we like to get a good result, right? So here I'm going to put in my share here, and you'd think I would know how to do all this stuff, but Zoom is annoying because there's all these different options for share. Okay, I think I'm here. So if you've ever spent time on like TeamViewer with me, you'll know that my favorite application is Paint, because I can draw and illustrate things in live results. So in my opinion, the machine should produce something that requires little to no manual work before you put it in the oven. Um, and so this we got to get better outer photography, but this is a bridge that I think is decent. We've got a nice surface finish. We don't have any defects or lines. The embrasures are well defined. And it is kind of a nasty, like tall implant bridge.
Yeah, yeah,
And yeah, so if you're not getting something that kind of looks like this, then
yeah, that's great.
you should be replying to the poll with a low score. um,
Yeah, yeah,
yeah, and so there's a big spectrum of
yeah,
what we get, and we'll jump into the one that Alex started with here.
yeah,
So these are
not the same.
yeah, spot the defect here. Um, you know, uh, I would say probably maybe 60% of inquiries that we get start with, hey, we're getting lines, right? Lines. I got lines. Um, and what a lot of people really don't realize is that there are so many different flavors of lines that we got to see it so that we can look at it and kind of start diagnosing it. And I really want to drive this messaging because the
Mm,
more that people know about certain kinds of defects and
right.
and basically what their root causes are, the better. It helps everybody. So this is a really pretty common one.
Mm.
And in the format that we're going to try to follow, and Alex, you might have to, like I said, bring me back on track on it.
Yeah, yeah,
Um, is we're going to talk about how the machine can make an input here, and then we're also going to talk about how the cam can make an input.
absolutely.
Um, and in a lot of cases, it's very possible that it's one or the other or both as a root cause. Um, so let's see what's going on here. So the defect that we see that we're not happy with is these horizontal lines.
Lines.
That's what we're going to pay attention. There are a couple other defects here, but we're paying attention to the horizontal lines. And so we're calling this roughing through finishing. If you're familiar with the process of milling, you'll know that, and if you watched a mill run before, we start with a big tool, mass reduction, and then we do a smaller tool, and then
Yeah.
we do a little tiny tool. So roughing happens with the big tool. And what we're
Mhm.
doing is we're doing mass removal of material. And that roughing tool, so here's one of my famous
I love it. Yeah.
crown. This is why I don't sit at the bench, by the way. So here's my crown, and I want to mill it. I'm going to draw my tool over here for use later. And I want to mill it. And so that roughing process, from the top, it's going to do passes like this,
Yep.
right? And it's going to reduce the material, but it's only going to reduce the material to close to the finished unit.
Hmm.
And in the CAM software, we call this the oversize. And that's an actual value that we can set.
Right.
And so when you see these lines, that means that the roughing tool is getting in to the oversize. So it's coming in here and it's gouging past that area, and it's getting into the finished crown. And so this
Hmm.
is actually a defect where we've milled past the precious surface of the STL. And what can cause it? On the machine side, if your disc has any relative motion at all relative to the machine spindle,
Hmm.
so like it's loose or it's sloppy or any of
Inside the
that sort of
holder.
thing in the holder, or the
Yep.
machine itself is loose due to wear. Any sort of motion that the machine doesn't know about can absolutely cause this.
Hmm.
Because what happens is, instead of, so it'll mill, and then when it goes to flip or something, it can't repeat it, and you'll end up with that oversized part of it. It'll be in here now, right? And then we'll start gouging because
Hmm.
the machine didn't go back to the right position.
Right. Yep.
Um, and so that's the machine physicality side on that. And then the millbox or CAM side is all about this value right here. So
Mm.
if we're not giving the tool enough material to bite here, it will bounce out of the cut, and it'll vibrate, and it'll do all kinds of weird shenanigans.
Mm.
And it can make this line.
Yeah.
So like default value, not that, it's 0.25. Decimal places are important, people.
Yeah.
Um, yeah. Oh, no. We're Yago would correct me. It is 0. It is 2.5. So that's our default value for oversize and millbox. So that means we've got a 1/4 millimeter of material that the finish tool gets to follow up and scrape away.
Yep.
So the machine just has to move a 1/4 millimeter somewhere that's not known in order to get that defect. Um, this guy's pretty common. If your
Mm.
machine's tight, brand new, awesome, no problems, then we got to go into the CAM. We got to look at that oversized value. Maybe
Yeah.
somebody changed it. Maybe you're on a super old version, all of the above, but my attention is going to the oversize.
Yeah.
Um,
I see a
yeah.
raised
So
hand. Put
yeah,
your question in the chat if you would, Digitech, Bolivia. Happy to answer it. And
sure.
what about another thing I'm thinking could happen here? Imagine I had, let's say, just the wrong tool in my finishing tool slot, but I have it programmed for, would that cause this outcome, or would that?
It would, so if you, for instance, swapped the tools, so like
Yeah.
I put my 2 millimeter where the 1 millimeter should be,
Hmm.
usually it's gonna try to pick up the 2 millimeter, right? But it's got a 1 millimeter, so immediately it's
Yeah.
gonna break that tool.
Oh
You're
yeah.
not gonna get it. You're not gonna even get close to a result. But if you have the 2 millimeter where it should be, and then you accidentally loaded a 2 millimeter where the 1 millimeter should be, now, so the cam is driving the tip of the tool right here, and that tip is following a path. It's just following
Right.
the
Around,
the
or
yellow
yeah.
brick road, right? And so it knows the radius of the tool. So on a 2 millimeter, that's a 1, and then on a 1, it's a 0.5, right? So if the CAM software is expecting the radius to be 1, but then you load in a tool that is twice as big, it's still driving it from this point. So
Yeah.
what you're going to end up with is you're going to end up with a
Grinding on the
severe, it's
yeah
going to be a
yeah.
severe grind. You're going to just destroy things
You'll
by
see
loading the
steps.
wrong tool. Yeah,
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 scallops out.
it'll be literal stair steps if you do that.
Yeah yeah.
Much worse than what you see in the picture. Um, and
Mm,
there's so I Alex, I could probably talk just on just this one for like 3 hours. So I'm trying not to go crazy. But there's other things that cause it. You've got
yeah,
collet maintenance,
sure.
how the toolpath
That's
is
loose.
being driven, like what flavor of toolpath is it?
Yeah.
There's a lot of nuance. We can talk longer at the end if there's Q&A or what have you, or if something
Yeah.
relevant comes up,
In the
definitely
cam
bring it up.
software, I think we even have a graphic that might show this if it's easier than pulling up the actual cam. But what does it look like? What am I looking at in the values there? I know it's in strategy editor, of course. We're going to go in and kind of look at this finishing toolpath,
Yeah,
of course,
yeah,
particularly. And then there's settings inside strategy editor. Thanks for pulling it up, that you can actually adjust the values on this toolpath with this tool. There you go. Yeah. And you can see this is within strategy editor. You can adjust some of the like
yeah.
the XY feed rate. Yeah.
Yeah, this is a screenshot of the parameters for a 1 millimeter finish tool. So you can see that the oversized value we were talking about is not populated. It's 0
Yep.
because we want to go directly to the surface. We're finishing it. And yes, that's the cool thing that Millbox really brings to the table is on the surface, it's extremely easy to use. I often tell people that I can train any barista from Starbucks to run Millbox in 5 minutes. To bring a unit in, make a puck, get it going, easy. But
Yeah.
if you want to
Sure.
dive in and you want to get deep and you want to go through all the super crazy nuances and get really nerdy about it, you can also do that. All of it's fully controllable. You can change
Yeah.
there's so much, there's
Yeah.
more that's customizable that I don't even like. I think I probably only know 10% of it.
Yeah. Yeah.
And so this is one of the main areas where you would be making changes if you want to affect the milling result with
Right.
CAM.
You'll
But
probably
comes
see
with it.
close to navigating there, but you go into, you must
Yeah,
have a
yeah, yeah.
Mailbox expert license, I'll say. So if you don't have strategy
Yes.
editor enabled on your, if you go into the configuration, you go to like tools configuration inside Mailbox, and then it'll have strategy editor as one of the left side options. If you don't have that, you have a standard or different license. So you might need expert, but once you have expert, that's a really simple upgrade. Then you'll have access to all of, for every tool path, you can kind of go into some of these details if you have the knowledge. Let's say that's where
Yep.
somebody like
So
Greg is really
yeah,
worth having. So
I
yeah.
was I was gonna put that disclaimer out here that if you go start changing things willy-nilly, just trying to figure things out by feel, what's gonna the at the low end, the result's gonna be broken tools, broken units. And at the high end, the result could possibly be broken machine. And so like I said at the beginning, it's possible for us to tell the machine to do something it can't do. We can
Mm,
drive the machine in, you can create a collision, you can add stresses that's not engineered for. So there's a giant amount of nuance. So if somebody's coming in here to change this stuff, you should at minimum have a very solid baseline knowledge about machining in general. Go on YouTube, watch 12 hours of machining videos, feeds and speeds, understand how that stuff works. Visit a website called the CNC Cookbook. There's a
mm,
lot of free information. Half of what I know I learned from that website, and
yeah.
then YouTube is the other half.
Okay.
So yeah, self-education for sure.
Yeah.
And don't go changing things willy-nilly just because you can. Um,
Yeah.
so yeah, that's that screenshot. We'll kill that. And
Let me
then
ask you a question, Greg. We've got
yeah, yeah,
one that came in here. So
sure.
asking same part, can this be caused by machine vibrations? If my machine's not in a stable place and shakes while it's milling.
So we always want the machine on a stable base. If your machine is on a card table, you're causing yourself problems. And so most of the machines that we have in this industry are considered desktop machines. They're under like 300-400 pounds. And when we're having this conversation with customers, I say, hey, whatever surface you've got, two guys, full-size dudes, should be able to stand on it and jump on it without it moving or flexing. And a lot of them don't pass that test. Like we've seen people having like, two tables that are those different levels and the machine sitting across it. And it's like, guys, it needs to be solid, it needs to be
Yeah,
rigid, and it needs to be level. Those
right.
are very important because the machine, if you study machining, you'll come across the phrase that everything is a spring, literally
Hmm.
everything that you touch in the physical environment is a spring. It
Hmm.
moves. And so is a machine. And so if you put a machine on a surface that's not level, it's gonna kind of take on that shape. And now it's not square. Now it's not straight.
Right.
And when we're trying to get precision and good surface finish and things like that we care about, you got to start with the fundamentals. Like that's hands down extremely important to answer your question.
Mm. Yeah, thanks.
Okay. We should start blasting through these because we're
Yeah.
we're on what one of 36.
Yeah, not quite, but yeah, let's keep it
Uh,
going.
okay. I'll introduce the next one.
Great.
So this one's super common, and then I'm pretty dang sure that everybody on this call has probably experienced a chip margin.
Yeah.
Um, and they suck because I'm trying to rush a case out the door. It was my last little bit of material in the corner of the puck, and now I got to deal with this and try to patch it with ceramic, in the morning so I can deliver it. And so yeah, chip margins generally they're a big source of waste. Um,
Mm.
and
Yeah.
so what causes a chip margin? Um, it really comes down to the material properties of zirconia. Like, what are we're machining this stuff, right? And it is essentially a dense shock. It's the worst thing on the planet to try to machine thin. It does
Hmm.
not want to be thin. It's fighting you every step of the way. Um, and so we've got to deal with the forces in the cut near the
Hmm.
margin and be very, very gentle to it in order to get a good result. So one of the most common thing that happens to that all softwares are doing is we're adding an offset value to the margin line to help it be more machinable. So if this is a cross section of my margin, your CAD software has added a value here, and that can be called like margin line offset or margin reinforcement or what have you. But that
Hmm.
value it exists in all CAD softwares. So if somebody calls me chipping margins, one of the first questions I ask is, "Hey, what's your margin line offset set at?" And generally, super safe 0.2. You're going to be extremely safe there, but nobody wants to grind that off, so everybody pushes the limit.
I think
A
point
machine
one
that's
five is mailbox's default, I think.
yeah,
Yeah.
yeah.
Hmm.
0.15 is generally pretty safe too. You might have a very small percentage of chipping,
Sure.
depending on the geometry of the specific margin. Like a veneer, those are yeah, forget those. Those are going to be hard to do no matter what. Um, and so that's super important. And then the other thing that causes margin issues on the machine is your tooling. So imagine if you're try this is my I gotta maybe come up with a different one, but this is one I use. So I've got a block of cheese, and this U-line pallet here is going to be my block of cheese. It's cheddar, by the way.
Very
Um,
good.
and so I've got my steak knife. This screwdriver will be that, and I can easily cut this really easily. Not really a big deal. I get a nice cut. I can even shave off a little tiny bit. Now I grab the knife by the handle, which is not, don't do that or by the blade. Don't do that at home. And now I'm just going to push the handle through the cheese. I can still do it, but now the cheese is just traumatized and it's split and it's gotten nasty. Um,
Hmm.
that's what's happening to your margin when you cut it with a dull tool.
Mm.
Um, and so what we're doing is we're traumatizing the material instead of cutting it cleanly. And we're micro fracturing it. So
Mm.
if you're seeing little chips like that under an SEM, there's also micro fractures everywhere
Mm.
else, which is not a good thing generally. So we want a good, clean, sharp tool. And uh,
Mm.
and in some scenarios, like some of our customers, we've used Millbox's highly customizable interface to do a dedicated margin line tool
Yeah.
that only does margin lines, and
Hmm.
it stays sharp, and we kill that tool well before it's done. Um,
Mm.
and that's how you keep your repeatability up. Um, and then we can also kill it with vibration. If you've not done your collet maintenance, or your spindle is bad, or you have that same relative motion, you don't have rigidity in the system, you're gonna break things. It's just not. It gets hard to do a thin feature. Okay, end rant on that, because we gotta keep moving on
Sure.
time here.
Yeah.
Um.
Yeah, and
Oh,
Greg
on
Mark
kit on
mentioned that strategy for the margin. If you're that's
yes.
a great way to and we don't need to show that necessarily, but it's great. There's an added tool inside strategy editor. You can enable an additional tool path that could, like Greg was saying, just have one tool that you keep
Hi,
always sharp just to go in and get that
highly
margin
recommend it.
if it's needed.
Yeah.
Yeah. So
I yeah, well, if you like to, reduce chipping and hand labor, it's definitely a pretty low hanging fruit, frankly.
sure.
Um, and
Yeah.
and so usually margin chipping, like it can always all these issues can be caused by the feed and speed, the parameters that the mill box is fed
Hmm.
by the human that made the strategy. Right.
Right.
So the strategy has set of parameters in it. We were kind of looking at a few of those on that last screenshot. Um, and so I somebody who knows strategies can easily make a set of parameters that makes complete garbage. It's so easy. I can make the best. I could make a
Sure.
$1 million machine run like crap with
Right.
bad parameters.
Yeah.
And the opposite is also true. We can use parameters to balance and get a good result on a inexpensive, crazy, worn out,
Mm,
sloppy machine in a lot of
yeah.
cases. And so the CAM software is an excellent tool when it comes to trying to go in and get things done for a
Sure.
good result.
Yeah.
Um,
Yeah.
yeah, and I'm hoping that maybe we encourage some people to start studying this, because like a lot of you know there's not enough knowledge, there's not enough people out
Right.
here who have done this stuff and are willing to put the time in to develop the skill set. But
Yeah.
uh
Should,
if you've
you should
got
create some courses.
dude, it's a I should probably
Yeah.
time I need someone to create courses for me. Hey, Alex.
Yeah. Nice.
Okay, so uh I was going to say that if you're a lab owner or your manager, you're working in a lab that's got, a bunch of machines, you're doing over 100, 200 units a day. Um, the amount of like bottom line business money, cash savings that can be
Right.
realized through optimizing this is insane. Like it can
Hmm.
literally keep you from buying, four more machines. Like you can
Yeah.
you can get way more efficient a lot of times, but it requires attention and a lot of trial and error work. You're not going to get it overnight. So
Hmm.
yeah, I'll stop on that rant. We'll jump into the next one here.
Yeah.
And
Talking about
uh,
chatter.
chatter, baby. This
Chatter,
one's
not
one of my
cheddar.
chatter, not cheddar. Yeah, that should be a saying, right? Um,
Oh, geez.
among
Yeah.
the hey, I'm hoping we got some, good, decent amount in there, and if we do, then it's highly likely that a few of them have seen a result like this.
Mm,
Um, and chatter is uh like, why do we call it chatter? Probably because it is kind of an
hmm,
audible sort of thing, and you can hear it when you're listening to the machine.
hmm,
Um, uh, Way more so in metal. Like if you're machining like metal, you can hear it. The machine's just screaming and it's nasty and it hurts your ears. You can hear it. The trained ear can hear it in zirconia too, and it's a little harder. Um, so chatter is almost always caused by a an excitement of the machine's like resonant frequency.
hmm.
Have you ever seen like somebody sings a specific note and then they shatter the glass?
Yeah.
So
Sure.
that note is at the resonant frequency of that glass, and
Hmm.
all the molecules just get super excited and then they blow up.
Oh, yeah.
Um, so chatter is a vibratory thing. It's that question earlier was kind of in reference to vibrations. And so on the machine side, um, the machine's job, and one other than just carrying out what the CAM software says to do, the machine's primary job is to have rigidity
Mm,
and not and resist the cutting forces.
mm,
So when you're cutting, that tool's blade's coming around and it's taking a bite out of the material's fighting back, right? And so it doesn't want to be cut. It's literally a battle that's happening at a microscopic level. And so the machine's job is to say, no, you're going to get cut. I'm forcing you to be
yeah.
cut. And it does that with rigidity. Rigidity is one of the most important things in machining.
Mm,
And that's a broad statement. That's not like
right.
here's a challenge for you guys. Go on YouTube, watch Titans of CNC. It's very entertaining. These guys are taking like crazy cuts in like super crazy alloys like Inconel and like titanium. Like what we do is hilarious compared to what they do.
Sure.
Um,
Yeah.
but a lot of what they're talking about is rigidity and the work holding and resisting that cutting force. And so what happens when you don't resist that cutting force is the tool bounces
Yeah.
instead of cutting. And so it's going doink, 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 doink.
Yeah.
Probably that's going to end up being a cut, right? Of me saying that. I'm going to throw that
Yeah.
out as a short.
Yeah.
Thanks, Alex.
Sure.
Um,
Yeah.
so it's literally bouncing in and out of the cut as it's passing over the the surface.
Yeah.
And so like this image down here, let me grab my pen. And I hate that every time I open Paint, I got to adjust the size of my thing here. But so check this out. So this is literally following. So the tool was
The
doing that
toolpath.
motion. Yeah.
Right.
And if you were to look at this toolpath from here and then take a cross section of it. So I'm looking down on the crown
Right.
and I'm going to here's the surface of my crown. And the tool path ideally should follow it extremely closely and we get the
Mm,
surface of the crown. But
right.
since it's bouncing in and out of the cut,
It's
what
wave.
you really
Yeah.
have is this bounce, bounce,
Mm-hmm.
bounce, 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 bounce. And then the next time it comes around, the bounces from the last one drive the new bounces and it
Mm,
gets more and more excited.
mm,
And so chatter is a pain. Machine rigidity, sharp tools, machines
mm.
up on maintenance. You've done your collet, you're not running a crazy old spindle, stuff like that. Now on the
Yeah.
CAM software,
Yeah.
another thing that really drives this is that same value in the first slide, which is your offset.
Mm,
And so if you can imagine the tool, the blade of the tool that's cutting, it's
mm.
sharp, right? It's not actually that sharp. It usually has a radius. If we magnify it really high, it's got a radius on the tip. And so if my oversized value is equal to or maybe even less than the radius of the tip of my tool, it's going to glance out when it tries to cut. It's not going to be able to cause the material to peel and flow out of the cut. And so that value, oftentimes, if we've got a loose machine, we can play with the offset value and we can reduce chatter significantly. And so I think the theme here is that if you wanna have if you got a machine that's beautiful and awesome, great. But if you've got a machine that might need a little bit of help, we can usually use CAM to band-aid it. Um, and then in some instances, CAM doesn't quite mix with the nuances of the machine, and we got to change it.
Yeah.
So
Yeah.
so yeah. Wow, it's 45 minutes
That's
already,
a good
Alex.
way to say it though, because even to mention maybe here, like maybe there is a calibration issue with your spindle in some way.
Yeah.
And there really is two ways to adjust that. And we would say the best thing for you to do is definitely to first rule out the mechanical. So it'd be great for you to tighten everything and make sure it's, right. But in the CAM, it wouldn't be impossible to create a, not saying temporary, it's temporary, a temporary compensation on the CAM software by providing the machine with different values to kind of recenter the 0 point of the machine on whatever the whatever's going on there, and that might help. Maybe more with our next one, if we're looking at
Yeah,
like our offset.
yeah.
But
I'll try to focus in on the
yeah,
calibration side of things on this guy here.
yeah. So maybe it's a good
Um,
transition. Yeah.
yeah, yeah. So this is another flavor of, quote unquote lines. And by the way, all the things we've talked about so far, with the exception of margin chipping, people call them lines. And so and so this is a very distinct kind of line that over here we call them an offset line. And it's because there's literally an offset.
hmm
So I've got, here comes my
One
pencil
big
again.
line. Yeah, not the striations, but the
Yeah, yeah. So we're oftentimes people have multiple types of defects. And
right.
so it's kind of hard to find a unit that has only one
Yeah,
kind of
this one's
defect.
got the last one and this one. Yeah,
Yep, yep, yep. But that's the point though. Galaxy, you're starting to recognize them, right?
sure.
Hey, that's chatter, right?
Right.
So is that. But what we're
And
talking
now,
about here is this guy right there.
absolutely.
And so here's another beautiful crown. Actually, we're going to do it differently. Here's the top of my crown. And then here is the bottom of my crown. And so if you've watched the mill before, you realize that it's going to mill the top or bottom, whatever, depends on the
Yep.
strategy first. And then it's going to flip, and then it's going to mill the other side. And so if the machine is not capable of flipping and going back to the same position,
Yeah.
you will get this line.
hmm
And it's distinct as a shift, and it's going to go one way or the other, top and bottom.
Yeah.
They're shifted, and so they're offset from each other, and that's why we call it an offset line.
Yeah.
Um, 99% of the time, just run the automatic calibration or the cut a cube calibration, whatever your machine does. The
Yep.
machine has lost its way. It doesn't know where the 0 point is anymore. And
Right.
so what a calibration does is we're retraining the machine, telling it where home is again. And like 90% of the time, a calibration fixes this.
Mm.
In some scenarios, when you have a physical problem, like say you've got like a worn ball screw. This is a ball screw, by the way. It's responsible for linear motion in most of our machines. Uh, if it's gotten play in it, or if it's loose or damaged or seized up or whatever, you'll get offset lines, and it'll be in the direction of the affected ball screw.
Hmm.
And so if it's offsetting, if we get an offset line complaint, the first question that I ask is, okay, hey, mill me a crown at 6 o'clock in the bottom of the disc with the buckle facing towards it. Okay.
Okay.
And then send me a picture of it. And then I'm going to look at that and I'm going to go, oh, the offset's left to right. All right. Now
Mm.
I know which axis is causing the problem just from
Sure.
that image. And so usually it's linear, sometimes it's a rotary axis, but
Hmm.
yeah, that's that. And you want to do your calibration.
Yep.
And then if you really need some magic, we can open up the cam, and we
Right.
can tell the machine. So some machines, and we've agreed to not talk about specific ones, but there are some very expensive machines that are on the market that actually require this to be done custom. Every single machine it's
Hmm.
got a different 0 point, and so you
Oh.
have to do a calibration and you have to enter that 0 point into the cam software,
Hmm.
so that the cam software drives the machine around that
Right.
hypothetical point. And so and then some machines have mechanical issues, right? So sim system actually has a virtual calibration that can be done.
Yep.
um and uh and it's again, it's kind of a band-aid option. So if you've got
Right.
a machine that's gotten sloppy over the years, then you can put off that expensive repair sometimes, and you can go into this option. And basically the process, we're going to mill this block. We're going to
Yes.
take very careful measurements. We're going to put the values in, and then Millbox is going to compensate for what actually came out of the machine.
Yep.
So we know we're pointing the machine to make these values identical perfect, but usually if it's screwy, it's not going to. And so then you take your target versus actual, and then you compensate and you create a good action. Um,
hmm
And so this is an option. Very few end users know about this, Alex. So
Yeah, yeah,
I'm hoping if you want to play with this, you need to talk to your dealer.
yeah,
Um,
absolutely.
FYI.
Yeah, I've seen this
Oh,
done once, and yeah, it's
it's
helpful.
powerful.
It's a temporary, like, it's there to help you. It's a great tool, and we want it to be there so we can fix a problem. As Greg's saying, if your machine's already kind of going mechanically, and then it's going to continue to have that trajectory, this you'd have to continue to do this multiple times. So it delays maybe some machine repair, but it wouldn't replace for the rest of the life of the machine a
Right.
fix needing to happen for the machine. But
Yeah.
hey, it can get you
Yeah.
by. So
Oh yeah, 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 and you know that's just driving that same theme is like, hey, a little bit of advanced mailbox or CAN software skill set goes a really long way
yeah, for
for your
sure,
for your for your bottom line, you know, because
100%.
you maybe you can put off a $10,000 repair for another 6 months,
And you'll save
right?
a
And
lot of
put that,
material, like you said,
yeah,
a lot of
yeah, and
tools. Yep.
but the thing with calibration is that it's a compensation for mechanical slop, um, or mechanical clearances. And anytime you have two parts moving next to each other, there's a clearance. And so over time, when a machine runs, it's always going to lose calibration over time. And so that's why it's something you're always having to do over and over
Yeah.
again. And so the looser the machine, the worse that's going to be.
Yeah.
Um, and I've been meaning to say that probably one of the number one things that you guys can do on your machine and your software is to commit to reading the documentation.
No.
Nobody, okay, I know I'm probably opening a can of worms here, Alex, but I can tell when I'm talking to a customer who's read the documentation and one who hasn't. It doesn't matter what they say. Um,
Okay. Yeah.
and oh yeah, I read it. No, you didn't. So the machine comes with a big book. Read that sucker. And if it's your employees, require them to read it and take a freaking test on it. And same with Millbox. It's a great website, the
Yeah.
help website.
I'll
There's
put it in the
so
chat.
much stuff. There's
Yeah.
so much learning. And it's powerful. Okay, cool. I knew we were gonna not get through everything
We're
else.
close. Yeah.
Okay, next one. I've got gouging. So a couple ago, I talked about the our surface of the STL file, the design.
Mm.
That surface is uh it's precious, right?
Mm.
We do not want to go past that surface ever. And so those roughing lines through finish, we went through the surface. And then in this example, we're also going through the surface, but it's going to look a little weird because it's only going to be in certain spots, and it won't be all
Yeah.
over the crown. It's not gonna present as a line like this guy. You know, it's all over the place, right?
Yeah. Yeah.
Um, and so we've also used the term 0 point quite a bit. Um, you have your disc, right? Kind of looks like that. And dead center in the middle of that disc, XYZ, there's a theoretical point in space that is called the 0 point. Everything that the machine does is referenced to that. So if
Mm.
I say, hey, machine, go to G55, which is referencing this particular zero point, and I want X
Mm.
to go 10 millimeters and Y to go 1 millimeter and Z to go 3 millimeters. The machine's going to do its best to carry out that command and go to this other point over here. And we're driving the tool, and now I've made a slot from the 0 point to that position.
Mm-hmm.
All the code is thousands of these commands.
Right.
And so and then it gets way more complicated when we add rotary axes. Um,
Mm-hmm.
and I'm getting to the root cause of this. Um, so in a linear motion, everything's pretty simple. The average brain can understand the math that's going on there.
Mm-hmm.
When you add in the rotary motion, now we're talking about trig, we're talking about crazy math. I can't do that math. But
Yeah, me
basically
either.
the machine has to physically orbit that point in space. And if
Yeah.
it's not orbiting it, then you get gouging.
Yeah.
And so the gouging problem is we've taken this disc, right? And we're gonna take it up at an angle, and I'm gonna drive the tool to a point that's referenced
Hmm.
away from that main that magical center point. Except because my disc didn't physically rotate around that point, now my tool is gonna go too far, and it's gonna overshoot or undershoot.
Yeah. Yeah.
But
Yeah. Yeah.
undershooting you won't see because it's
Mm.
not going to touch the finish. But overshooting, it's going to overshoot right
Go
into
into
your
the
unit.
part. Yeah.
Right. And that's all of
Because it
this
didn't
is
rotate
rotary.
enough.
Yep.
Yeah.
Or no, or rotated too much, one or the other.
Oh, sure.
Right.
Yeah. Yeah.
Yeah. And it's so the short of it, I guess, is that it is not hitting the target that it was told to go to.
Right.
Um, okay, so how do you alleviate that? There's mechanical. A lot of times, mechanical is the problem here. Something ain't straight, something's bent, you know, out of calibration, that kind of thing. Not maintenance. Um, and then the other thing with some machine models, we've got to do a physical test. We got to take measurements, and we have to input values into the CAM software so that it knows where that 0 point is in that hypothetical space. And so if that's not been done correctly, or maybe the machine slipped since it was done last, then you can also get this issue.
Mm.
So yeah, that's gouging. We do see this one quite often. And it's definitely fixable. So don't deal with it. Um, all right, I got 3 minutes. We wanted to talk quickly about oh no, that's the last one.
It's the last
Um,
one. I have a
yeah,
question.
yeah, yeah, yeah.
Everybody get
Go
your
for it.
questions in if you have them. We
Yeah,
can go ahead and start populating that. Yeah, we've got 3+ minutes. I'll ask the first one as we're thinking, but thank you, Greg. I mean, yeah, I definitely learned, especially that last one there. Thank you very much.
we could go way deeper. We should do like an 8 hour, Alex.
Sure. Yeah. Well, hey, Dentian wants to do a course. Happy to do it with you. Yeah. Someone writes in, this is back a little bit, but we didn't answer it, and I might be able to answer it, but you can elaborate. They're asking, what's the best tool or what do you recommend for finishing interfaces in titanium bars? Sometimes those parts are not so flat and smooth. Actually, I'll let you answer just because the titanium throws me off. I think T-tool immediately, but then you go
No,
ahead
so
and
yeah, he's talking about finishing the interface.
mhm.
Um, T tool is applied to a tool channel, specifically when you're doing an angle
Right.
screw channel.
So on the metal, it is
Yeah, yeah. So
diamond
let's see,
or whatever
I'm gonna
coated
do
tool. So
a new one here. Okay, so first answer to that question is use the tool that your machine manufacturer tells you to.
yeah.
Don't deviate. Don't try to save money with a cheap eBay or Alibaba tool. Don't do it. You're asking for trouble. Because the tool has to match the cam. If you throw off that balance by changing the tool, even if you think it looks the same and it says on the package that it's compatible, most of the time they're not. There's something different about it that's going to affect your result. So on interfaces, it's going to depend on what kind of surface feature you're getting. But like, let's say we've got like an MUA, right? Something like this. And on the inside, you've got scalloping. This we could fix with strategy, and we could densify the tool path so that your scallops get smaller, and you can make a better surface finish. Um, the feed, speed, oversize, all that stuff comes into balance here for surface finish. And if you're talking about like the lip or a flat surface at the top of this geometry, those should be machined with a flat profile tool. If your strategy is machining that with a ball in, you're always going to have little tiny racetracks on that surface. You got to
Mm.
use a flat. So if you want to talk more about that, you can find me. You can go to dention.com. We can chat, or you can email me, Greg@dention, and I'm happy to have a conversation about that.
Yeah,
What
absolutely.
else we got? Anybody
Yeah,
else?
great one. Someone asked about mailbox training options. That's more of a general question, and I
That's a
can
you
just
question.
answer that. Yeah, of course. It depends on who you are. Right now, our dealers offer some different training if you contact them directly, depending on who your dealer is. But I am putting one in the chat right now. I think we're happy to promote Level Up's Mailbox Academy course
Oh yeah.
as a great option. And Mike Webb is a great mailbox expert who is offering an official mailbox course for labs. If you're a dealer, of course, you can contact us and we do education. But in the US, I believe right now, the only official course would be through Level Up, and certainly others are welcome to create some. But that's a great
Yeah.
resource. And I know Mike did an advanced class in August, I think. So contact him. He'd be happy to put one together. I know. So
Yeah.
that's
He's
him.
he's doing he's doing a great thing. He's taking a focus on education, guys, and you want to affect your bottom line, you definitely need to know him and talk to him and work with his team.
Yeah, he's probably here somehow. Yeah. Good. All right. And then I've got another one from Lewis of Gravity. Hey, Lewis, good to see you again. Can
What's
adjusting the
up?
spindle speed or feed rate, can adjusting the spindle speed or feed rate without making extreme changes help improve the margins when milling more brittle materials like Emax or amber mill?
Um, I don't know what Sim's official answer on that is, but I'll give
Yeah.
my official answer. Never, ever, ever do overrides. Ever, ever, ever. Okay, why? So, and we're talking about at the machine. So, a lot of machines have the ability for, and I'm assuming this is what he's talking about. A lot of the machines have the ability to end user change the spindle speed or change the feed rate. Um, those are very important parameters that have to be in balance, and you have to take into consideration the machining properties of the material, how your tool works, the condition of the machine. All these things are in balance, and usually the default setting that comes with your stuff is going to be good enough. If you're getting a bad result, then you should be talking to somebody who has a cam expertise to make you a bespoke adjustment to get that bad result out of it. Don't ever use a
Mm.
machine override because you're blind. You're throwing crap at the problem blind, and you're not doing it the right way. And in fact, I have advocated for that feature to be removed from all your end user interfaces
Yeah.
because it in our case, we touch hundreds of machines,
Right.
and that one always just causes problems. It never helps. Um,
Mm.
and the right way to do it is to make an adjustment at the cam software so that we're driving the machine right. If you're not driving the machine right and you have to remember to make an override adjustment, and then your employee's sick and then somebody forgets and you break an entire day's worth of production because
Mm.
somebody forgot to do that, that's just a bad way to do things. Okay, I'm not passionate about that one at all.
Yeah, very good. Good. Well, and that was actually our last question. So if anybody has
Cool.
any other questions, we'll, go ahead and put it in right now. Otherwise, I'm gonna put some info up on the screen for Greg in case you want to reach out to him. I've got a QR goes to his website. You can reach out to him if you need anything mailbox or machine related. He's your guy. Otherwise, Greg, thank you so much. Really appreciate your time. And if you need to get in contact with us here at Sim System, here are our global offices in the Americas. It's support.americas at simsystem.com, and we're happy to help you anytime. But let me see. No other questions. So, Greg, thank you so much. I really appreciate doing this with you. And yeah,
Yeah.
any final words from you?
Yeah. Thanks for the opportunity. Anytime. And if anybody who's watching or listening wants to listen to me rant for 3 hours, just give us a call.
Absolutely. Will do. Well, thank you, everybody. We really appreciate you being here today. Yeah, thank you very much. And I hope it was helpful. Like I said, if you have questions, reach out to us. Otherwise, hope you have a great day. Good luck in the lab. Thanks, everybody.
Awesome.
All right. See you later. Thank you.
Are we off?
Okay, we'll ask this question since we're still on. Someone asked, how can I treat equator lines?
Ooh,
Yeah.
fun. How many people we still got in here?
Who's still in? You got 29. So if you're still here, a
Okay,
can of worms is being opened.
now we're
Stop the.
opening the can of worms. So when we were putting this together, um, I deleted that one
I
out of the
remember.
conversation just because I knew it would dominate the entire thing. Um, and in equator lines, that's the most challenging one to be completely, straightforward. Um, so I think I even have a screenshot thingy on those. Maybe that's where you guys got the idea to ask about it. So this one's equator line, and the definition of an equator line is we have. Oh, am I not sharing anymore? I think I'm
No,
maybe
I
not
must have
sharing.
it. So let me.
No, no, I'll actually I don't know how to reshare here. Oh, you got to drop it, I think.
Okay.
There we go. You should see me now. This is equator line. You guys seeing that?
I am. Yes.
Okay, rad. Um,
Yeah.
okay. So equator lines are the same all the way around the unit.
Mm-hmm.
It's the same defect, and it follows the equator, or the height of contour, right? So whichever term you want to use. But see, all of these have that in common. The line is following the highest point of the unit, and it sees and basically that's the if you look at the crown from the burr or tool's POV. So like, here's my tool. If I'm gun sighting down this, I can see the very edge of the crown. That's the height of contour,
Right.
or the equator. Okay, so uh, what is causing it? And I'll explain what it causes, what's causing it, and then we could talk about some of the ways that it can be mitigated. And so essentially, when we're milling a unit, my ball end tool is up here, and it's doing its thing. We're milling the top of this unit. We're going back and forth, and then eventually, I'm going to make myself a mobile tool here. Eventually, that tool is going to transition to the side of the crown. And now, what's cutting? Not the tip of the tool. The
Right.
side of the side of the tool is cutting.
Yeah.
And so the dynamic that's happening, and you can kind of put this in your mind's eye, is it's kind of like the chatter problem. It is a bit of a
Mm,
resonant frequency issue, but it has to do specifically with the engagement of the side of the tool.
mm,
Um, and so all machines, 100% of all milling machines worldwide, all industries have something called runout. Um, and so in a perfect world, and if I could draw a straight line, the tool is going to rotate perfectly around the axis of the spindle. It'll never deviate, not even by a freaking nanometer, right?
mm-hmm.
But that's not reality. That's not physics. So all machines have a bit of run out. So the tool is naturally swinging a bit. It's doing this, right? And so the effective shape of the tool when it's running is actually kind of a little bit like this,
Right. Yeah.
because it's doing a pendulum motion,
Mm-hmm.
right? And again, this comes down to rigidity.
Right.
And so this gets worse. As rigidity decreases, this type of thing gets worse.
Right.
So what's going on? We've got our tool. We're transitioning to the side, and then our tool will start to kind of slap the side of the crown as it's working its way around, and it will penetrate that STL surface, and you
Mm-hmm.
will get the equator line defect.
Yep.
And so the root cause of this is vibration, lack of rigidity, and then and usually it could be maintenance, it could be wear on the machine, it could be all kinds of different things. But the concept you have to have in your mind is rigidity. Um,
Yeah.
and so how do we mitigate it? That's the biggest question, because yeah, if we're seeing this, we don't want it. We want it to be gone.
Mm-hmm.
So I'll talk about machine first, and then I'll talk about cam. There's two approaches. Sometimes both help.
Yep.
We want to do everything we can to keep that tool from having run out. That means buy a good dang tool. Don't buy cheap tools. Okay. If the tool's cheap, it's going to cause you problems. That's it.
Yeah.
Pay for a good tool. And then if you check that box, make sure that your spindle is healthy. If it's screaming and making noise and you can hear it, that's a problem. Um, and then your collet, which is the part inside the spindle that needs regular maintenance. Um, if you haven't serviced that, or if it's damaged or worn, if someone dropped it on the floor, the collet is in charge of telling the tool to be in the center. If it's dirty
Yeah.
or damaged or worn, it's not going to be in the center, and it's going to be wobbling all over the place. So often I talk to people and they're like, "What's a collet? We've had the machine for 4 years and we've never taken it out." Okay, this is why we're getting these problems.
Right. Yeah.
And by the way, I've got like a 20 minute, 30-minute video on our YouTube
Yeah.
channel that goes in deep on collets if you want to know about that. We're doing collets, we're making sure everything's clean, maintenance, everything to the book, to the documentation. If we still get this, then we can use CAM software to
Yep.
help it. And so there are some parameters that we can do. So by default, in a lot of the Millbox builds, and even other CAM softwares do this. So you've got your center line, the actual, gosh darn it, I wish I could clip right. The actual equator of the unit is a center, right? So we're driving the tool to that center. All these little lines right here. We're going to go to the center, and then from the bottom, we're going to go to the center from the top. So most softwares drive the tool slightly past the center in order to prevent any overlap lines, which is a
Yep.
problem that doesn't really happen very often because we're driving it past the center now. You can play with that value sometimes to reduce the size of this. So if you're running past center a lot, that means we're doing a lot of the side engagement with the tool. And
Yeah.
so you can reduce that value and you can bring
Right.
this thing into more acceptable.
Right.
Nuance to that matters on the machine, matters, everything matters. And then the other thing you can do is you can run a sharper tool.
Yeah.
And so the thing that's driving this again is vibration. So vibration excites runout, and then it's a self-feeding feedback loop. It gets nasty. And so if we can reduce the energy that's required to make the cut, then we're going to get less vibration, less runout, less parting line. And so one of the common recommendations that we make is if you're milling zirconia, you're probably using diamond tools. Diamond tools are great. They last forever, and they keep your wallet healthy over a long term because your cost per unit. But what not a lot of people know is that diamond that's been applied to the tool, it has a known thickness, and it can be anywhere from a couple microns up to 15 microns or so. But what happens when you put a thickness or coating on a sharp edge is you create a radius. Now it's got a blunter nose. Diamond tools are not as sharp as non-diamond tools. Sharpness reduces cutting forces. So if you want to experiment with this, you can run a good quality carbide tool, like either OEM or one of the high-end suppliers, not a cheap one. Run a good quality non-coated tool for your outside finish, and we'll have lower cutting forces and less parting, and less not parting line, equator line. So that's one thing. And then if your CAM dealer is willing, Sim System also has a CAM solution for this that works in most cases. There's some nuance to it, but effectively what we do is we throw a tiny little protective surface here on that height of contour, which makes the tool, when it comes down here, kind of just glance off a little bit in this direction.
Yeah, it moves away.
It's called a protective surface. And it just helps drive the tool away so you don't engage the side, and you get a better result. The big nuance on that is that it's machine, the value that works is different for every machine. So when you have
Yeah.
multiple machines, it's kind of hard to implement this in a production environment.
Mm,
Um, and then like Alex, I've fed Yago quite a few ideas on other ways to drive the tool.
sure. Yeah.
But current state is that's available, so you can talk to your dealer and they can
Yes.
put that in.
Yeah. Yeah. It's in strategy
Yeah, yeah,
editor as a option that can be enabled, but
right,
talk to
yeah,
your
yeah.
dealer. They have access.
Indeed,
Yeah.
indeed, definitely. I hope that answer's satisfactory.
That was good.
But it's definitely a touch point because we talk about it a lot over here. Any other questions come
Yeah,
up
we
while I
have
was
two. Yeah,
cool.
Sergio, good to see you, man.
What's up,
Regarding
Sergio?
yeah, Sergio Magana. Yeah. Regarding securing a desktop mill to the table, is it or is it not recommended securing it? I observed users attempting this and I advise against it, suggesting instead that they invest in a more stable level table to minimize vibrations. So securing versus
I'd want to
stable
see the
table.
I would want to see the table. Um, like if your machine's moving around, it needs to be fixed one way or the other. It shouldn't be able to move around or flex. Um, and so honestly, Sergio, the ultimate would be securing it to a stable table. Do both. Um, but most of the machines are heavy enough to where if they're sitting on a platform that's stable and level, you don't
Mm,
have to tie it down. It's fine. They got rubber feet. Um, it's usually not a problem. It just needs to be level and stable.
yeah. So kind of his expectation.
I
Yeah.
yeah, I agree with you. If they're putting it on a card table or some janky,
Yeah.
IKEA thing, like go to Uline. In fact, I'm still sharing, I think, right?
Yeah, you
This
are.
guy, I think I've probably sold, I don't know, 50 or 60 of these dang tables for Uline because they're cheap.
He's popped up
Um,
right away. Yeah.
no, no, that's
Oh, that's the
by
wood
the way,
crate.
if
Okay,
you want to ship a machine, that's the
yeah.
that's the crate we use.
While you're pulling it, he said,
uh
"Would a vibration pad help?" Just your thought on that at the same time.
Uh, it's not a 3D printer.
Mm,
3D printers can 3D printers that have like a lot of high speed tool head motion. They can benefit from vibration isolation pad. We just want rigidity. That's all we want. And so, yeah, I doubt you'd see a noticeable difference by putting it on a piece of rubber.
mm,
Okay, so this guy right here, they make them in all kinds of convenient sizes.
there
They're
you go.
pretty dang accessible. Um, and so you're going to pay, $300 plus $80 for them to freight it to you. And you can literally have these things next day. And I think the capacity is like 3,000 pounds. No dental machine weighs 3,000 pounds. They're cheap, accessible, and they even sell casters. I like to have my
Sure.
machines on wheels because when I reorganize or have to do maintenance, it's really nice to be able to pull it off the wall.
Yeah.
Um, and we do a custom build on this table, by the way, where we integrate all of our air handling, our power distribution, our suction unit, our PC, and then we've got custom casters that we machined parts for that are super rigid. They're much better than the Uline ones.
Mm,
And then the machines on top. It's a sweet self-contained
yeah.
solution. But anyone can do this. Just go to Uline and buy the table.
Yeah. 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 We had 5 in our mill room back.
Oh yeah, I remember I set that up for
Yago
Mike
has
like a
them
couple.
now. I think
Oh
in his
yeah,
garage.
yeah.
So yeah, at least one. So
Those
yeah,
those have the Uline caster. I'm not a super fan of that. They
sure.
kind of they're kind of a little wobbly. Uh if you want some really good casters, call me. We've got the right ones.
Yeah.
Okay.
Good. Last question.
That's that. Last one.
Tool. We'll see if we get besides Roland regarding tool quality. What other manufacturers do you recommend for good tools?
Okay, another hot button topic. So those of you who know me know that I probably have a bit of a bias because I was previously in charge of Sierra Dental Tool,
Right.
which is the maker of the best tools, demonstrably best. I'm not just tooting the horn or anything, but they are the best tools. Um, and uh, and I know a lot about what goes into it and what goes into a coding and what goes into the engineering and the applications. That
Mm,
is an entire science. And so Sierra, I gotta say Sierra, and I hate to just put a plug in, but either OEM, so original from the machine manufacturer that you bought the machine from,
Right.
or Sierra. Um,
Mm.
and because those two are trustworthy. Um, and so there's a lot, like, it's one of the most attractive consumables for a dealer or even a dude, on eBay, or some random guy who's bringing them in as carry on from, back east, somewhere, selling these things, because it's the razor blade, right? It's a great consumable thing to sell. And they're available for very cheap. You can get a super cheap tool, but what you're getting is, in a lot of cases, a literal piece of garbage. Like, it'll work and it'll cut a crown, but if you want a really good result that you can count on all the time, every day in and day out, invest in a good tool. Because with a cheap one, you might get lucky. Maybe you get lucky a few times and it lasts and you get a good result. But you're going to get a bad batch at some. The
Mm.
tool's going to lose its edge immediately. You're going to break, 3-4 days worth of production before you realize it. And now any bit of unit cost that you would have saved on the tool is immediately flushed down the
Mm.
toilet in headache and troubleshooting and material loss and human labor time. So you got to think about it in total. Look at your business from the top down and say, hey, we can pinch pennies on these little items, but in the aggregate, it just ain't worth it.
Mm.
So yeah, either OEM or Sierra,
Mm.
and I'll probably get an email, but yeah,
This is
that's
after
my
hours
opinion.
here.
Oh
Yeah,
yeah. Oh, we're not like broadcasting anymore, are we?
it's here, but it can be edited out. Yeah, if needed.
Oh no,
So
anything I'm saying, I don't mind saying in front of
yeah,
1,000 people. It's all good.
yeah,
Um,
Ok-
was that the last one? Hopefully I answered that
yeah. You did,
good
and thanks for
enough.
your answer. That was great. And that was our last question. So
Cool.
think we're that with that we'll end officially. Thank you, everybody.
Awesome.
Thanks for everybody who
Great.
stick around for that bonus episode here. And
Definitely.
again, thank you for being here. We're gonna log off now. Thank you very much, Greg. Appreciate just
Yeah.
access to your brain and the insight. Thank you very much.
No worries. You have a good one, Alex.
Yeah, you too. Thanks, guys.